My fabulous chemistry minions, video number 8. We are getting into covalent bonding now, and the first thing we're going to do is learn how to draw these molecules. I'm going to be at the board drawing a lot today, so I've got the camera turned a little bit differently than before. Covalent molecules are made up of two or more nonmetals. We're going to need some practice. There is a bit of a trial and error to this. I've gotten away from like the long, dragged out method that I used to teach or learn in honors chemistry or AP chem. So we're going to do it a little bit simpler this way, but it's got a little bit of a trial and error to it. So sorry about your luck. You got to take the good with the bad. All right, so you need to know that a single dashed line shows a bond, and that each bond is got one electron from each atom. So each bond counts as 2 electrons. So we'll use that when we count. And then every atom must be written, and then all the octets for all the atoms must be full, except for like somebody like hydrogen in this first example, who only needs a duet. Okay, so the first rule of thumb is to draw each element's regular Lewis dot diagram, how you were taught. So I got hydrogen, and I got chlorine, and that's right off the reference table. Hydrogen has 1 valence electron, chlorine has 7. Okay, and it's important to do the one at the time, or first two together, one at the time rule, so that we can make these shapes right. And it says draw a loop surrounding the unpaired electrons in every atom to one of another atom, of course, and then there can't be any unpaired electrons left where we've done something wrong. So if I were to loop these two like that, that is where the bond is going to be formed. And so now I redraw this molecule, and wherever I drew that red loop, I'm going to put a bond now. And notice the bond is directly in between the H and the C. So I'm going to redraw. I'm going to say H, starting with Cl. So this is, I'm mad at me already. I know, there you go. Cl, got it. Cl, and then that loop is the bond. And that bond, and it doesn't have to be touching. Okay. Just needs to go in between the two. It's going to take up most of the space, like that. Boom, there's my bond. And I got to bring these paired electrons along with it. Now, that is a completed diagram, and we're done. What I want to show you is a little bit of extra to make sure that we can count. So there are 2 electrons in every bond. So if I look just around the hydrogen atom, boom, there's 2 electrons, because there's 2 electrons in that bond. So he's happy. And then if I look all the way around the chlorine atom, he's got 1, 2, 3, 4, 5, 6, and 2 in the bond. So he's got his 8. His octet is filled. I don't need you drawing circles around everyone. This is like a mental check that we do to perform to make sure that we've completed the diagram. And there it is again, HCl, and that's how it's drawn. Perfect, and it's what we call linear. So we need to do this for a few more pieces. So I'm going to hop to it with this pen and see what happens. So I'm going to draw my H's, and then I'm going to loop them. So now there's a loop in between the 2 H's, so I redraw that H bond H. And we'll notice that both have their duets satisfied. All right, now we have H2O, and here comes one rule that was not in those rules, so you might want to write this on the side. Whichever atom has the least number of them, in this case oxygen only has 1, he will be the central atom, and that will help these things. So when I draw my oxygen, might as well draw it in the middle, and it helps me get an idea of where these bonds are going to happen, because now I'm going to put my H here, and I'll put my H here, because I see that these are going to loop here and here. Now that is on the west side and south side of the oxygen. I don't want you to get confused. I was not putting in an electron. I was talking about the west side and the south side. It's where my bonds are going to be when I redraw. So start with my O, put a bond down to my H and a bond to my H. Bring in my lone electrons, and there is a very sloppily drawn water. Okay, the bonds don't need to be touching the elements, but they do need to be the only thing in between the elements. What I don't want to see, and I don't want to see this, I don't want to see their electrons unpaired like that in there. I don't want to see something like that. Okay, because now it's like more electrons than should be there. Okay, because there is 2 in the bond, so just you need to count that as the 2 that are there. There are 2 there. Bring in my lone pairs. That is a little bit neater version of water, and it's important that we draw it that way. A lot of times you'll see it kind of turned like this with the O with the H's down. Notice it's the same thing, just rotated. Okay, either one is correct. All right, so again, N is the lone atom, so I'm going to make sure that one's in the middle. N's got 5 valence electrons, so I can see ahead of time where these H's are going to go. And I will just loop them up. When you get good at this, you can sometimes just draw the central atom and figure everything out and move on from there. But he's going to have his 2 electrons, his 3 bonds, H on either side. That is ammonia at H3. So we're doing good. We got a few more to go. I got some double bonds to show you when things get a little crazy. And then there's 1 triple bond, and we'll be done with this video. So we just got to keep following along. So here we go. I'm going to do oxygen. I know that I'm going to draw this oxygen facing that way. I'm going to draw the other oxygen facing it, just so that it makes looping these things up easier. It's a kind of a trick I've learned from doing this so much. So there's a loop and there's a loop. Now there's 2 loops. 2 loops means 2 bonds. So I need to redraw oxygen. 1, 2 bonds is going to look kind of like an equal sign. Can't forget to bring down my paired electrons. And if I take a second here to do what I did on the last slide, I'll show you that it works. So again, around this oxygen is 1, 2, 3, 4, 5, 6, 7, 8 electrons. And around this oxygen is 1, 2, 3, 4, 5, 6, 7, 8 electrons. And each oxygen's octet is filled by creating a double bond. So I'll redraw quick so it's there. And it's up to us to just get these right. So C is the only lone atom, so he's the central atom. The other rule is carbon's always the central atom. If carbon is present, he is the central atom. And carbon, remember, is 1 at a time around the bus, and that's key. To believe it or not, silicon kind of is also. Okay, silicon is also. So oxygen, 1, 2, 3, 4, 5, 6. Oxygen, 1, 2, 3, 4, 5, 6. Now notice how I did those opposite. It's just to make those lone electrons facing the middle. If you don't do that, you're going to be fine. Your loops are going to just kind of go a little bit around more, but it all means the same thing. It all means the same thing, because a loop there and a loop there means that there's 2 bonds between that oxygen and carbon. So between this oxygen and this carbon, there's 2 bonds. And then when I loop up these 2, I'm going to loop those top 2 so these don't cross. Again, 2 more bonds between the next oxygen. Bop, bop, bop. Bring down my paired electrons. And this is carbon dioxide. These 2 are very, very common for you to be able to have to draw. And Si does hybridize like carbon, by the way. I know I didn't teach that to you in atoms, but it's because we weren't going to be seeing it. I didn't want to overcomplicate things. Okay, so again, this is going to look just like carbon dioxide. I'm going to, whoops, that was a mistake. Can't loop the same electrons on the same atom, silly notes. But I can loop these 2 and these 2. So notice my loop-de-loop looks a lot similar to carbon dioxide. And then I just redraw Si's got 2 bonds to this oxygen, 2 bonds to this oxygen. And now we have double bonds down. We have one more complicated one to do. It's called a triple bond, and these things do exist. Nitrogen is the most common example. So nitrogen has 5 electrons, and every nitrogen wants to make 3 bonds. So when I have nitrogen by itself, these guys are going to bond, these guys are going to bond, and here goes one of those loop-de-loops that go either side. So you'll get a lot of those if you don't turn them in on each other. They'll look like that. And I can just redraw now. I have 1, 2, 3 bonds between my nitrogens. So 1, 2, 3 is a triple bond. Looks like that. I have a lone pair on either one. I tend to put them there just so that they're far apart. If you put them both on top, it's okay. Those, I'll let you put those two dots anywhere on that nitrogen atom you want, as long as there's two on one and two on the other, because it has to even out, and it evens out this way. Because see, look, I got 1, 2, 3, 4, 5, 6, 7, 8 electrons around that nitrogen, and then I have 1, 2, 3, 4, 5, 6, 7, 8 electrons around that nitrogen. So you need a lone pair on each one so that they're even. And I'll just redraw real quick. You draw this enough times and you can almost just memorize how to do it. And with that, we just got to remember a few things, right? So a single bond is one dash. There's 2 electrons in that dash. It's one pair of electrons. Regents questions tend to distinguish between 2 electrons or one pair of electrons. You have to read very carefully, and I think it's unfortunate because now it becomes a reading test and not a do I know what I'm doing test. 2 dashes have 2 electrons each in them, so there's 2 pairs of electrons or 4 total electrons, okay? And those questions creep up. And 3 dashes, 2 in each, of course, so there's 3 pairs or 6 total electrons being shared between these 2 nitrogens. And with that, you got some practice to do. So do your practice, check your work. See you tomorrow in class.